Now, let's take a look at example number 3. And this is another one where we're going to see that we have the same basic idea. We're going to try to use the intermediate value theorem to help address a question. Let's see, we want to show here that the graph of this function obtains a y value of -5 at least one time. Okay, now I have no idea what this graph looks like, nor do I really care. In fact, I don't even want to know what the graph looks like, because I don't think I need to. All I need to understand is that I am going to be trying to go to this function, and I am apparently trying to hit a y value of -5. And in order to show that this is going to be possible, I just need to get a point below and above that line and confirm that this is a continuous function, and I'm done. So let's try it out. Is this a continuous function? Well, let's see. It's kind of made of two pieces that are being subtracted, the sine function and the function of x. And these are both continuous everywhere. So I'll say here that we know that f of x is continuous everywhere since it is made from two continuous functions which are continuous everywhere. Okay, so I have continuity. I know when I play connect the dots, I have to do it without picking the pen up off the page. But I still need two dots, one low and one high. Now, I like to try to do as much work in calculus as possible without the use of a calculator. In fact, I'm always going to be asking that we always provide exact values in this class, and we'll see more about what we mean by that later. But we'll see it as first in this example. Notice here that there's a lot of values that I could plug in, but I'm going to try to pick values that are easy to work with. So let me go ahead and state some values that I think are easy. So I'll start by saying we see that, well, what about f of 0, right? That would be a pretty easy value. Because I know how to compute sine of 0 minus 0. Remember that the sine of 0 is just 0, so this total result is 0. Apparently here, the origin 0, 0 is a point on this graph. Now, when I pick another value, it would probably be a really bad idea to do something like sine of 1, or like to pick 1 and then try to plug it in, because I don't really know what like the sine of 1 is. But there are plenty of other values that I do know. Maybe I can do something like this. Maybe I can do something like pi. There, oh, right, because I might know how to do the sine of pi. All right, so let's see. The sine of pi, what's the sine of pi? Well, the sine of pi is going to be 0 minus pi, so that gets me negative pi. And notice I'm writing that as an exact value. Exact means I'm not rounding it. But I have a slight problem here. We know that pi is roughly about 3.14, so that's only going to get me to, I don't know, maybe around here in the picture, and that's not really good enough. I need to go below 5, or below -5, I mean. So, okay, this is going to happen to you sometimes. We might just have to back up and try again. What else could we work with here? How about I pick something even bigger, like 2 pi? So I'll do sine of 2 pi minus 2 pi. Now, what's the sine of 2 pi? Well, that would be 0. Minus 2 pi gets me negative 2 pi. So if pi is roughly 3.14, notice I can say here this is squiggly equals, it's roughly about 6.28. The exact value here is going to be negative 2 pi. This value over here is rounded. And we always want to work with exact values in our classes when we state numbers, but sometimes we'll need to look at a rounded value to get a sense of what it actually is like where it falls on the number line. And that's why in between these, we don't put an equal sign, but we put a squiggly equal. Notice though, this is a value that's going to be low enough. So if 2 pi was over here, negative 2 pi would be down here. And since my graph is continuous, I know that eventually I'm going to cross. So there is definitely going to be some value where we hit -5. So we can write our conclusion. By the intermediate value theorem, there is a number c in the interval from 0 to 2 pi such that f of c equals -5. And we've done it. There's got to be a time then where this function hits the y value of -5. So hopefully the intermediate value theorem and its use here is starting to feel maybe slightly systematic. Again, if you can understand the picture and what you're shooting for in the picture, you'll oftentimes remember what you need to write down and what you need to show and justify. Of course, if you have any questions, practice with the worksheets and let me know via email or during office hours.